Have you ever looked up at a plane and wondered about the invisible system that keeps our skies safe? It's not just the pilots and the air traffic controllers, it's a world built on data, governed by a really complex alphabet soup of acronyms. Today, we're going to decode that system, from the global rule makers all the way down to the data that shows up inside the cockpit.
And it all really starts with this one critical sentence from ICAO, the International Civil Aviation Organization. This isn't just some vague warning. It's the fundamental reason this massive global quality management system even exists. Because in aviation, bad data isn't just an inconvenience, it's a direct threat to safety, period.
So how do we actually fight that threat? Well, for any pilot, probably the most important tool they have, long before they even start the engines, is information. But can't just be any old information. It has to be standardized, it has to be verified, and it has to be delivered in a very, very specific way.
And that specific delivery method is called the Integrated Aeronautical Information Package, or IAIP. The easiest way to think of it is as the official library for a flight. It's the main product that comes out of what's known as the Aeronautical Information Service, or AIS, and its job is to turn all that raw data into usable, trusted intelligence.
Now, this AIIP is actually broken down into a few key parts. First, you've got the AIIP, the Aeronautical Information Publication. That's like the permanent encyclopedia of the skies. For really urgent real-time stuff like a closed runway, you've got NOTAMs. Then there are AICs, or Aeronautical Information Circulars, which give more general advice. And finally, a pilot gets what's called a PIB, a Pre-Flight Information Bulletin, which is basically a personalized briefing of all the NOTAMs relevant to their specific flight.
Okay, so we know what information pilots are getting, but who makes the rules for all this data? This brings us to the global safety net, this whole network of organizations that create and enforce the standards, from the highest international level right down to the local airport. And right at the very top of that pyramid is ICAO. As a UN agency, it sets the global standards and recommended practices, they call them SARPs, that all member countries agree to follow. This is absolutely crucial because it ensures a pilot flying from Tokyo to Paris is operating under the exact same fundamental safety language.
So if ICAO sets the aviation rules, you can think of ISO as providing the blueprint for how to follow them. The International Organization for Standardization's famous ISO 9000 series is the universal playbook for building a solid, quality management system, or QMS. It's all about ensuring consistency and quality in the process.
And here's how those big global rules get applied on the ground. ICAO standards flow down to a national regulator, usually called a Civil Aviation Authority, or CAA. They're the national referee, making sure the rules are followed. And they oversee the Air Navigation Service Provider, the ANSP. The ANSP is the local team, the ones actually managing air traffic and creating those information products that pilots depend on.
All right, so we've got the product and we've got the rule makers. Now let's see how it all comes together by following a single piece of data on its journey. Just imagine a surveyor out there measuring a brand new runway. How does that simple measurement get from their notepad into an aircraft's navigation system without a single digit getting corrupted?
Well, that data follows a super strict chain of custody. It starts at origination with our surveyor, then it goes to processing, where the Aeronautical Information Service, the AIS, checks and verifies it. Next up is publication, where it gets formatted into something like a NOTAM or an update to the AIP. And finally, it's distributed to the end user. The key thing here is that at every single one of those steps, there's a risk of error, and the system has to guard against it.
And that leads to the million-dollar question, right? How does the system make sure the data is trustworthy at each handoff? It's not based on just, hoping for the best. It's based on some really clever technical guardians.
One of the most important of these guardians is the CRC, or Cyclic Redundancy Check. The best way to think about it is like a unique digital fingerprint for a block of data. When data is sent, a CRC value is calculated and tagged along with it. The receiver then does the exact same calculation. If the fingerprints match, perfect, the data is unchanged. If they don't, the data is corrupt and it gets rejected on the spot.
The system also knows that not all data is created equal. Some info is more important than others, and that's where data assurance levels, or DALs, come in. As you can see here, data gets classified based on risk. Routine data has let's say, a reasonable integrity requirement. But critical data, we're talking about things like the precise coordinates of a runway, that has an incredibly high bar to clear.
So how high is that bar? For critical data, the required integrity level is 1 × 10⁻⁸. What does that actually mean? It means the system is designed to allow for an undetected error in no more than 1 out of every 100 million data items. Just think about that. It's a staggering level of precision, and it's basically the mathematical bedrock of air safety.
So, last piece of the technical puzzle, how do you make sure all these different people and organizations in the data chain, the surveyors, the airport authorities, the AIS, are all on the same page? Well, that's the job of the SLA, or Service Level Agreement. It's the formal contract. It's the glue that defines exactly who is responsible for what, making sure everyone is accountable for the quality of their piece of the chain.
So all these acronyms, all these processes and checks, they're all part of a much bigger philosophy. And to really get it, we need to look at two ideas that work side by side to keep us safe: quality management and safety management.
A quality management system, or QMS, is all about meeting requirements. Is the data accurate? Is it on time? But a safety management system, or SMS, is focused on managing risk. It's constantly asking, what could go wrong here? You can think of it like this. The QMS builds a reliable, high-quality foundation, and then the SMS uses that foundation to proactively hunt for and stamp out potential dangers. They're two sides of the same safety coin.
And here's the cool part. Neither of these systems is ever finished. They are built to constantly get better, using a really simple but powerful method called the PDCA cycle. Plan, do, check, act. You plan an improvement, you do a small test, you check the results to see if it worked, and if it did, you act by implementing it everywhere. This little cycle is the engine that makes sure the entire safety system is always learning and evolving.
So, we've gone through the organizations, the products, the data chains, the whole philosophy behind it. We've decoded the alphabet soup. But after all of that complexity, what is it all really for? What is the single, simple, ultimate goal of this entire massive global system?
It really just comes down to this. All of the layers of process, all the checks and balances, all the international agreements, they exist for one reason, and one reason only: to create a moment of absolute, unwavering trust. The trust that allows a pilot anywhere in the world to look at their instruments and just know, with near perfect certainty, that the information they see is correct and that it will guide them home safely.